Okay, see, before we go to the next exercise, here we have to learn another theorem. It goes like this: the lengths of tangents drawn from an external point to a circle are equal. Okay, the lengths of tangents drawn from an external point to a circle are equal. Suppose it is like this. Suppose this is a circle. This is a circle. So this is an external point, say P, and from this external point we can draw two tangents. We can draw two tangents at the most. Okay, two tangents. Suppose this is point A, and say this is point B, and say this is the center of the circle. Okay, what we do, we join these two and join these two, say O is the center. Also we join the external point to the circle. Okay, so P is an external point. The lengths of tangents drawn from an external point. So P is the external point. From this point we are drawing PA and PB, two tangents. Okay, drawn from an external point to a circle. This is the circle with center O. These two are equal. PA and PB are equal, or AP and BP are equal. Okay. So we consider, let PA and PB be two tangents drawn from an external point P to a circle with center O. Okay, center O. To prove PA equals PB. Okay, so this is the description of the figure that we have taken up. Okay, so these are P and PB are here the two tangents drawn from an external point P. So we are going to prove P and PB are equal. Okay, so join OP, join or draw. Line segment OP is drawn. Line segment OP is drawn. Line segment OP is drawn. OP OA. Okay, let me write like this: OP OA and OB are drawn. Because these are not given in the question, in the theorem. No, only these two. Okay, are drawn. We are drawing from our own. Okay, so we join OP, we join OA, we join OB. Oh, okay. So OA and OB are radii. Now we can go to prove that PA equal to PB. Okay, this is very simple, and this is very important. Although it is very simple, but it is very, very important. Okay, you should know that. Okay, let us go to proof. Okay, proof. PR, it's proof. Okay. First of all, you know tangent is perpendicular to the radius through the point of contact. Okay, so since it is a theorem, since tangent is perpendicular to the radius through the point of contact, Okay, so therefore angle OAP equal to angle OBP equals 90 degree. Okay, since tangent is perpendicular to the radius to the point of contact, therefore this is tangent, this is radius, so this 90, this is tangent, this is radius, so this is 90. I am writing directly. or here we can write tangent perpendicular to radius. This is the reason, since. Okay. So first of all, now what we'll do, we'll go to these two triangles and we'll prove these two triangles congruent. Okay. We'll take these two triangles. Okay. Now, in triangle, say OAP and triangle OBP. These are the two triangles we have taken, OAP and OBP. So we'll find some equal parts, equalities. Okay. And before we go to equality, first we have to decide the congruence criterion. Okay. So you see right angle, common hypotenuse, and these two are equal. So we'll be going for RHS rule. So first we write angle. Angle OAP equal to angle OBP in these two triangles. Okay. Why? Each 90 degree. Each 90 degree. Okay. Second point, OP equal to OP. OP is the hypotenuse, here common hypotenuse, common hypo you can write, no problem, or only common side. Okay. And OA equals OB, because O is the center, A is a point on the circle, B is a point on the circle, so OA and OB are what? Radii of the same circle. So therefore, what is happening? Triangle OAP congruent to triangle OBP. Okay, what is the criterion? I told you already. By RHS congruence, I just write rule, congruence rule. But when you write, better write congruence rule. So PA, PB, coming easy, corresponding parts. PA and PB are two corresponding sides. Okay, so we come to the answer, means the proof finally. So therefore, okay, we go in the reverse manner, because I named it PAPB. So PA equals PB by CPCT, corresponding parts of congruent triangle. So that is our question, that prove PA equal to PB. So hence proved. Here, in addition to this one, here I tell you that also by CPCT these two angles are equal. That means the line segment joining the center to the external point bisects the angle between the two tangents. Also these two angles are equal by CPCT. It means that two tangents subtend. These two tangents subtend equal angles at the center. So these two conditions here I have not mentioned, but in solving problems we may be using this, that the line segment joining the center to the external point bisects the angle between the tangents. Also another one, the tangents subtend equal angles at the center. Okay, so remember these two additional points, and here we have proved that PA and PB are two tangents from an external point, they are equal. Okay.